Frequency response for series parallel loaded. This is an equivalent circuit for series parallel loaded circuit. This circuit is compromised between the characteristics of series loaded and parallel loaded. Then, using the voltage divider rule, the frequency domain, the voltage gain is given by j omega equals to V naught divided by Vi in terms of j omega, which is nothing but frequency domain, is equals to 1 by 1 plus Cp, that is the capacitor in parallel branch, divided by Cs, that is the capacitor in series branch, minus omega square L Cp plus j omega L by R minus j divided by omega Cr. Here we have only one L, that is inductor in series branch, so I'm just representing with the L here. Let omega naught equals to 1 by square root of L Cs be the resonant frequency and Qs equals to omega naught L by R be the quality factor. Then substituting this, we are going to get that j omega equals to 1 divided by 1 plus Cp by Cs minus omega square L Cp plus j Qs of omega by omega naught minus omega naught by omega, which equals to j omega equals to 1 divided by 1 plus Cp divided by Cs of 1 minus u square plus j Qs of u minus 1 by u, where u equals to omega naught by omega. Then the magnitude of j omega is given by 1 divided by 1 plus Cp by Cs 1 minus u square plus Qs square of u minus 1 by u whole square. The entire denominator is another square root. The figure shows the magnitude plot for the voltage gain for the above equation. For Q equals to 1 to 5 and Cp by Cs equals to 1. This inverter combines the best characteristics of the series loaded and parallel loaded, while eliminating the weak points such as lack of regulation for series loaded and load current independent for the parallel load. As parallel capacitor gets smaller and smaller, the inverter exhibits the characteristics of series load. With a reasonable value of parallel capacitor Cp, the inverter exhibits some of the characteristics of the parallel load and can operate under no load. As Cp, that is parallel capacitor, becomes smaller, the upper frequency needed for the specified output voltage increases. Choosing the parallel capacitance Cp equals to Cs, that is series capacitor, is generally a good compromise between the efficiency at partial load and regulation at no load with a reasonable upper frequency, that is Cp equal to Cs. For making the current to decrease with the load in order to maintain high efficiency at partial load, the full load Q is chosen between 4 and 5. An inverter with the series parallel loaded can run over a wider input voltage and ranges from no load to full load while maintaining the excellent efficiency. This is regarding the frequency response for series parallel loaded.